Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 11, Chapter 4, The Stages of Development, Discrete Activities, Part 2. Requirements, Definition, and Management. Requirements are those system features that are required, hence the name, for the system to be acceptable to the stakeholders. The goal of the requirements specification is to understand what must be done to build the system the stakeholders need and want. The purpose is not to write heaps of documentation, but instead to communicate and review the understanding. To do that effectively, something had best be, written down. Some specifications can be written, used, and then not maintained. Having served their purpose during development, they can be archived, not thrown away. You don't need to keep all aspects of your requirements model, just the most essential portions that define the necessary scope of your system, the parts that describe the requirements your system must fulfill. The work products here may include the technical requirements, a use case model, and a user interface model. Software requirements analysis and design. Analysis is a detailed examination of anything complex to understand its nature or determine its essential features, a thorough study. It is generally done by breaking things apart into their constituent components and then analyzing them. Understanding what the system should do is then followed by describing how to do it. The what is the set of requirements, the how is the design. The design is comprised of a variety of artifacts. They may include various models, deployment, object, physical data, security, threat, user interface, and that sort of thing. A system overview document provides a high-level view of the overall system. Architectural high-level design partitions the system into its constituent components and defines how those components interact, creates the engineering context for the solution. Detailed design. Where necessary, a detailed design specifies or expresses how a particular part of the overall solution will be coded. It is not necessary to produce a detailed design for every part of the system. Where the solution logic is tricky, a detailed design step first helps clarify the solution, and second, provides the developer with a checkpoint. The detailed design can be reviewed before programming it to prevent or reduce logic errors in the code. Design models should be as simple as possible and archived once their value has been realized. Some recommend that the best place to document the design is in the unit tests and source code. That may be true for a detailed design, but not the architectural design. Essentially, be selective about the design documentation that is managed. That is not to say that design documentation should be skipped, ignored, and abandoned. Keep necessary documentation, at a minimum, the system overview document and physical data model for permanent and critical design diagrams, such as sequence diagrams or state machine diagrams for important system functions. Design documentation is not only useful for organizing the development effort, but also for long-term maintenance of the system. To do so, the design documentation must be kept consistent with the actual code of the system. Failing to maintain the design documentation will increase the disparity between the system and its design. This renders the design useless, wasting the investment and risking the long-term health of the system. Software construction or implementation. A great enemy of high-quality software is the WISCY, pronounced whiskey of course, syndrome, the why isn't somebody coding yet syndrome. Unfortunately, agile methods sometimes reinforce this approach or attitude towards software system development. Code, the program, as the solution to the problem is the point of all the processes and non-code products produced by those processes. So, why don't people just write the code and dispense with all the other mumbo-jumbo? Simply because that approach has been shown not to work, time after time after time after time. Writing the solution is the actual coding part. Before that is started, the programmer has to be sure they are solving the right part of the problem. Depending on the complexity of what is being developed, the programmer may write pseudocode and have that peer-reviewed and then turn that into code. Simple modules can go directly to code. Unit testing is the testing that the developer does to convince themselves that the module is complete and correct and won't break when integrated into the rest of the system. Once unit testing and peer reviews are complete, the code is made available to be integrated into the rest of the system. Simply, apparently, the process is iterative and is basically code and fix. First, write and express the solution, actually a tiny part of it. Second, check it for correctness, which is unit testing. Third, fix any detected errors, which is debugging. Fourth, lather, rinse, and repeat. Software test. Until the unit test process, most of the quality assurance processes in the development effort have been various forms of reviews and inspections. These reviews and inspections are far more efficient at finding and fixing defects than any form of testing. Until code is written, no testing is possible, in any case. Once there is a code base that can execute on real hardware, it can be tested. There are several flavors of software tests. First, a unit test, see above, performed by the module developer before the source code is made publicly available. Next, it's integration testing, which is performed by the developer and a quality assurance specialist, if one is available. As parts are bound together into software subassembly, this tests the subassemblies. Next is system testing. Once all the different subsystems have been integrated into the final system, test the system as a whole. And finally, acceptance testing, often done by the customer or end user with development or quality assurance support. This test formally demonstrates that the system's requirements have been met to the customer's satisfaction. When there is a large number of customers, then this often takes the form of beta testing. Other different kinds of tests focus on specific characteristics that are not necessarily important in every system. Regression testing is essential during maintenance. Security testing, performance testing, stress testing, and the beat goes on. The exact suite of tests that should be executed depends on the problem domain and the non-functional requirements for the system. Tests may or ought to be automated. Developing a suite of automated tests is a significant undertaking, but once developed, the tests are an essential contributor to the process and system quality goals. Automated tests are, in many ways, just more code. They need to be designed and validated. Deployment. Deployment puts the system into the production environment and makes it available for use by the customers or end users. The deployment consists of delivering all the system components, including all necessary user documentation. A reasonably complex software system usually includes some form of training as well as a support system that can handle and manage customer or end user reported defects and requests for new features and enhancements. The initial deployment is probably as easy as this step will ever be. Later updates to the system during maintenance may include executing special systems-level routines to update or upgrade the data maintained in the system for the customers. Few things are as exciting as a one-way database change on customer data to support a system upgrade. Software maintenance. Maintenance is an odd creature. Of all the disciplines discussed, only maintenance qualifies as both a discrete or product-oriented and continual or process-oriented discipline. As a discrete process in development, it takes the output of the previous activities, development and deployment, recording and reporting defects or enhancement requests, installing emergency patches, monitoring system performance, and that sort of thing. Each delivery will be maintained until it is replaced, and then the replacement will be maintained. It is also a continual process, activities conducted to keep all of the information within the project consistent and of high quality. Everything that is done to preserve the value of the software over time. This mostly addresses correcting reported defects in the system and its documentation while it is being developed. That ends Chapter 4, Stages of Development, Discrete Activities. Join us next time for Episode 12, Part 1 of Chapter 5, What Exactly Are We Building? Vision and Requirements. That's it for me, for you, for now. Be careful out there. Bye.